Biodegradable plastic films. The consequences of the excessive use of resources and emissions generated during the life cycle of conventional plastics are not a secret. Year after year, landfills take up more space. Plastics are very practical, but have a big footprint on the environment since they are not biodegradable. All possible alternatives have been explored, one of them being starch-based plastics, although they don't perform that well compared to conventional plastics. There is also an ethical debate about using food for product manufacturing, but what if the raw material came from a waste product? Due to the quantity of Ecuadorian banana exported, there is a large amount of material available. Thus, the solution should be 100% biodegradable with sufficient mechanical properties and using these wastes. Thus, biocomposite films of banana starch from peel and bacterial nanocellulose as reinforcement appear. Bacterial nanocellulose provides several benefits by improving mechanical properties, barrier properties, and being more stable in water. In 2022, 6.2 million tons of plastic waste were generated. That same year, 39% of the total plastic produced worldwide was destined for packaging. In 2023, the website Statista recorded a market value for biodegradable plastics of $5.2 billion, of which $4 billion was the market value for packaging. 5% of the market equals $200 million. As for nanocellulose, the market value was $350 million, of which 210 were the market value of bacterial nanocellulose. Again, 5% of this segment correspond to $10 million. In Ecuador, there are approximately 500 companies importing plastic raw material, 600 of plastic processing businesses in Ecuador, and $2,000 million from production revenue. In this slide, we can see some of the dry banana peel and bacterial nanocellulose extracted in Espol University in Guayaquil, Ecuador. We also see how it relates with some of the Sustainable Development Goals, which will be the number 9, industry, innovation, and infrastructure, number 12, responsible consumption and production, and lastly, number 13, which will be climate action. Little Composites intends to follow a custom manufactured business model and obtain revenues through business-to-business sales. The added value for these plastic films are that it is biodegradable, it uses export byproducts, it also enhances starch-based polymers, barrier and mechanical properties, and also nanotechnology is implemented in a form of a blend. And the segment for this product will be green buyers, people who are interested in being sustainable and contribute to this goal. Also green businesses which will be these green buyers, but in a bigger share, and also corporations wishing to move away from conventional plastics. As we know, companies are starting to move from this kind of conventional plastics to more sustainable and eco-friendly options. Little Composites films offer many advantages over conventional plastics. Since this product is tough to be manufactured here in Ecuador, it has the potential to reduce logistical costs by not including shipping from most of the plastic manufacturers, namely China. It also meets several sustainable development goals directly. It also stimulates Ecuadorian research and development area, which is very underdeveloped. And also, it gives a new set of properties to plastic films for packaging applications. My team is composed of 3 students. Milena Coloma is a biotechnology engineering student in UNEMI University in Ecuador. Myself, Angel Socola, and my partner Ismael Isurieta. We are both materials engineering students in Espol, Guayaquil, Ecuador too.